Last time we programmed out some primitive objects, and this is a great way to start so that we have our objects going. But if we want to have more than a handful of objects, this is not an efficient or effective way to program anything. So what we're going to look at is how we can do this better so that we can create instances of any one of these objects, and by instances that's plural, so 1, 10, 20, 100, 1,000, 10,000, it doesn't really matter. We can just keep adding more and more instances or copies of that object. Each one will move and animate independently. It will have its own personal X and Y, all these things. So that's what we're going to look at next. I've made a new project, so I'll start clean so it's a little bit easier. And as always, we're going to need a couple things here. We need our setup. And within the setup, I'll just go with the standard 800 by 600 size. And then I, of course, will need my draw. So the two functions that we use in every project. If I want to have multiple copies of my object, what I do is I create what is called a class. So the easy way to add that additional file that we need for this, right now we have our main program file, is I click on the arrow and I choose new tab. And then when I do that, it allows me to add to it. So I am going to, on this, make a couple different classes so we can see how this works. So the first thing is I'm going to make one of my balls that can bounce on the edges. So I'll call it edge bounce. Now you will notice I capitalized the first letter in this because when we make a class, it is convention that in a class name, it starts with a capital letter. When we make instances of the class, variables, those are all lowercase, but our class name should always begin with a capital letter. So we use the word class, we have the name of our class, and then we have our curly braces. Notice there's no parentheses in front of these curly braces. This is the syntax for creating a class. Now, a class object, because really what we're making is objects, and we'll have multiple instances of these objects. So classes are used to create or construct objects. So those objects, they're variables that they have. Their X, their Y, width, height, speed, etc., color. These are all, we refer to those as properties. So these are properties. If we think of a person has different properties. They have a name property, they have an eye color property, a hair color property. They may have an X and Y property. Their geolocation values of where they're located, latitude and longitude on our planet. So I'm going to start with our properties. Then every class requires a constructor. And finally, the things that a class object knows how to do. The functions that we're going to list here are called methods. So they're functions the same way that we have our setup and draw functions, but when we put them inside a class, we refer to those as methods. So the properties are the characteristics, the variables that are part of this object. The constructor constructs it, it initializes everything. So the constructor is very much like setup, where we list our variables, then we, inside of setup, we give them values. And then the methods are the things that this object knows how to do. So with this, we're going to set this up here. And what I can do is, because of how I'm going to choose to animate it this time and the numbers I'm going to work with, instead of using int like we did before, I am going to use float. Now, the difference between an integer and a float number. An integer would be like a 5 or a 6 or a -1 or 0. Oh, that should have been a comma. 0. So those are all integers. Floating numbers would be 5.678 or -0.325. So float refers to numbers that have a decimal point and something after it. So it allows us to have a little bit more precision. So I am going to need an x, a y, a width, a height, and then I will want my horizontal speed, which I'll use for Vx, and then I'll have my vertical speed, Vy, and then I'm going to just have the generic speed value that I'm working with, so I can in one place just change a number and that updates the possibilities of speed for this. So we'll just list it like that. We're also going to have a color variable with it, and I'll just call that C. And then we'll define that out here inside our constructor. So our constructor will be an edge bounce. So I'm creating one like what we did before with our primitive objects where it bounces around. So we repeat the class object name, parentheses, and then curly brace, return twice, curly brace, and then up arrow. Now I'm ready to start defining these. Now, as we define these and want to work with it, I'm going to need to define them not in the order that they're listed up there, because my x and y are going to be eventually determined by my width and my height. So I'm just going to start out and I'll say width is equal to 50, height is going to be equal to 50, and then speed. Now speed is the general how fast I want it to be going, and in this case I'll just start out with 5. Now my x, well, look at, once we get this class object working, then we're going to look how we can randomly position it somewhere on screen. We'll have random speeds, we're going to have random colors and all of that, so we'll figure out how we can create that difference between them. But first we're just going to start out with something. So I'm going to say my x is equal to speed. Oh no, x isn't equal to speed. X will, I was thinking to Vx. I was thinking ahead of myself there. X, we'll just start it out and I will just put it in the middle. Y, I'll just put it in the middle as well. Now my Vx, I'm just going to set that equal to speed. My Vy, I'll just set equal to negative speed just for fun. So that means that it's going to move up and it's going to move to the right. And then my color, when I want to assign that, I can go into my color selector and I can just simply choose a color, copy that, and then I can go and paste that in. And that now gives me a color. So now I've initiated all of the variables for my object. The next thing we need to do is figure out what it knows how to do. And what we want our objects, all of our visual objects that we put on screen are always going to have two methods. And if we always name them the same, it's going to make it easier when we write the other code as part of our program. So with this, it's a method that doesn't return anything, so we use void. And our first method will be update, and our second method will be display. So what we're doing is we're separating out the logic of how do we update our object on screen and then how do we display that object on screen. So our update is going to simply say x plus equals Vx, and then y plus equals Vy. Simple enough. Now let's do a little boundary check here. So I'm going to repeat what we've done before. So if our x plus the width divided by 2 is greater than the total width of the screen, or x minus our width divided by 2 is less than 0, So we're trying to make sure it stays on the screen, so when it hits the edge it bounces. We don't want it to go partially off screen. Curly brace, return twice, close curly, up arrow, and then Vx times equals -1. So we're repeating the lessons that we've done previously. So that takes care of our horizontal component. And now we can repeat that same thing with our vertical. So I could copy, paste, and change things, or just simply reference what I'm looking at on the previous one, but change all of the x's to y's, w's to h's, width to height, etc. And then it's going to be the same. So we find out if we've hit the bottom of the screen or if we have hit the top of the screen. So if either one of those situations are true, at that point we want our Vy times equals -1. So if you do copy paste, it's not uncommon. You forget one of the y's and you leave it as an x, or vice versa, and then you're like, why is it misbehaving? That's just really weird. Okay, so now we have set up our movement. So we update our position, and then we update our Vx and Y when we run into the boundaries. Now we can just simply set our fill equal to our color that we've created. And now I'm going to just draw my ellipse at x, y, width, and height. So now I have created my class object. So again, our class is properties, a constructor, and methods. Methods are what it knows how to do. The constructor is where we give its properties values, and the properties are simply the unique properties that will be part of this object. So to create a variable to hold this, what I do is say edge bounds. So the same way we had ints and floats and strings and all these other variable types, we also can now have our custom classes. So I call this edge bounds. I could have called it anything. We just always want to make sure the name starts with a letter, not a number. That's critical. So I'll say edge bounds here, and then I am just going to call this B because it's a ball. And now to create an instance of this so I can use it in my program, I just say B is equal to a new edge bounds. A couple parentheses because this now calls. So this statement right here calls this constructor, and it then makes a new copy and assigns all of those values to it. So now B is just a reference to that new one, and now I can say B dot update and B dot display. Now if we hit go, we can see how it's moving. Now notice I don't have any clear background or anything going on, so it's not clearing the background. And if I refresh this, we'll see it still is going to go exactly the same each and every time. So if I did want to clear the background, I can say background 128. Try again. And now we can see once more how we now have this ball bouncing. And if I wanted a second ball, I could do edge bounds B2. B2 equals a new edge bounds, B update, B display, etc. So we will do that. But first we're going to modify this a little bit. We're going to look at how can we add in some randomness. So the method random inside of processing, when we want to work with it, there's a couple of ways we can do so. So if I use random and said random and now just put a number in here, like number 5, it's going to return a floating point number between 0 and 5. So that's how this works, is it will give me a value between those. So now if I run this, now if I run it again, we can see how each time the x value is different. So now if I just change this to speed right there, and each time I run it, we can see how now I got a value that for my x value is very close to 0. Another option that we could do beyond a single value here is we can now add to it. So processing's random function. So most other programming languages, if I say random, it just returns a value between 0 and 1, and then we multiply that by the range that we are looking for. So that's the standard way of doing it. But processing, because it is designed to make things easy for you, I can do it between negative speed and speed. So if I do it, so sometimes it will start going left. And other times, okay, it's still going left. Oh, and now it's going right. So we can see how it's giving us a random value between, in this case, -5 and 5. This is why I wanted to use this speed variable, so I can decide if I want to make that range bigger or smaller. I can simply enter it in. So this is one way that we can do it. The other way that we could pull it off is I could say random, and I would go speed multiplied by 2, so double the speed, so it's giving me, a random number between 0 and 10 instead of 0 and 5, but then we subtract 5 from it. So if it gave me a value of 10, I take away 5, it gave me that maximum Vy of 5. But if it gave me a value of, let's just say 0, and I subtract 5, we now have -5. So these two methods are pretty similar. And in other programming languages, we would just do random. And processing does require me to put something here, but in, say, JavaScript, I just do random with parentheses, and it gives me a value between 0 and 1. I could just say random 1, and then I can multiply that by the range I'm looking for, which is double my speed, so speed times 2, and then subtract the speed from it. So then that gives me a possible range of 0 to 10, because speed times 2 is 10. So random number between 0 and up to, but not including 1, and then we can subtract 5 from that. So all of these give us the same kind of range. So you can see how the minus speed to speed is very clean, because that is part of what processing has done, is tried to make programming a little bit easier to work with, so we don't have to do these kind of mental gymnastics with that. So now if I run it, well, now it started out going down and left, so we got two negative numbers for our speed. So if we can get an, oh, that's left and down again, and down, right, and pretty much horizontal, up and left. Again. So when we do this, you can see how we get these different ranges. What I also want to do is I want to set up my X and Y so that it doesn't start in the same place. Well, actually, before we do that, let's just make a second version here. I'll just call this B2. B2 is equal to a new bounce. And then B1 update, B2 update, and B2 display. Now if we run it, oh, forgot my semicolon. So it's telling me error on void. I'm like, this is all right down here. Now look, there's my red underline telling me it's unhappy. I go all the way back here and realize I forgot a semicolon. All right, try again. And now we have two. And we can see each one is moving at different speeds, but they're both bouncing off the wall. They are the same color though, so we're going to take care of that. So creating a color. What we can do with this, instead of hard coding that value in, is I type the word color, put some parentheses, and now within the parentheses I need to define out the red, the green, and the blue color component. And we've talked prior that we can use our RGB values, which range from 0. So if I look in my color picker, we're at 0. That's black. If I go all the way up to white, come on, well, approximately white, it's 252. So the three values can are between 0 and 255. So we have a range of 256 to choose from there, but it's 0 and 255. And the random numbers do always start counting from 0 when we generate a random value in processing, so just keep that in mind. So we can just enter in our numbers as needed. So you can see as I move through here how I'm getting different red, green, and blue components. And now if I move through here and move the hue, you can see how these numbers are all changing with it. So the way that we can implement that is using random. And random, I'll just go 255, comma, random, 255, comma, random, 255. Now if we run this, we'll see that the objects are indeed different colors. Different colors. Different colors. Sometimes the random numbers generate two things that are close to each other. This time you can see how they're at near opposite ends of the color spectrum. So the random that it's using in the world of randoms is technically, it's more along the lines of a pseudo-random, so it's not a true random. So if I were designing, say, a Vegas gambling machine and had to meet certain standards for randomness, I may not fully qualify here, but I could possibly skew things because, if we did want to control the random range on it, so I could skew it in the favor of the house, you can certainly do that. But now we can see we have random speeds, random colors, and now we're going to make random starting positions as well. So what I want, just going to kill the speed here for a moment and run it so we can see. What I want is I want my ball to be starting for sure inside the margin. So I want it to be inside the margin. So I'm going to give it a little bit of space to do that. So instead of starting at 400, I use random. And what I'm going to do is I want a number that is, I want to position it similar to some of the things I showed with the speed times 2 minus 1. But in this case, we will do width, the full width, but I want it to have a potential margin of one kind of width, or a margin of 50 all the way around. So then I'll go 2 times W down here, and this is part of why I needed to define W first before defining X. And now that gives me a random number, but it's going to be against the left margin, so then we want to also move it over by 1 width. So what we're doing is we're creating a random number range that is 2 widths, or in this case 100 less than the width of the whole sketch. So this is 800, but I am getting a number that's between 0 and 700, and then I'm adding 50 back into it. So then that means my possible values are 50 to 750, so I'm getting that 50 pixel margin. Now I'll repeat that for my Y value as well, but use height. So random minus 2 times H plus H. So that guarantees that they will always appear somewhere on screen. They won't be possibly appearing partway off screen and breaking our code. Oh, probably want to turn my movement back on, but you can see they did start at different locations. And neither started in the middle. So they're always going to be starting in different places, and they're going to be random colors, and random speeds. So this is good. So we've been able to customize this class so that we can have two objects going. And once we wrote the class once, we added two. And if I now want to make 4, 8, 10, 50, 100, 1,000, we can do that. The method that we're going to use to control multiple objects, both creating them and then handling their draw methods, is going to be a loop. Now there are two loop methods inside of processing. Now if you want to get to the reference, know that we can go and choose the online help. Now it'd be nice if I could search for it and it would find it when I type in the word for, but it's too generic. But what we are looking in the reference here, it's under the control section, because control is where we're controlling our code, where we've used things like if else, and we've used our different greater than and less than and or and. So we've used some of these controls on it, but the one we're looking for is a for loop. So processing has for loops and while loops. Now while loops, we could use a while loop for what we're doing, but I think the for loop ultimately it's a little bit better suited to what we're trying to do. They both work in a similar manner, so they execute something. So a while loop, you specify what is the condition in which it's going to execute, and while that condition is true, it keeps doing something. The problem on a while loop is it doesn't have a predefined amount of times it's going to execute, so depending on what you do, you could lock your program out. Because when a while loop is running, nothing else can take place. It will run until it eventually is true, or your program crashes. One of those two things. So we're not going to do a while loop. We're going to instead do a for loop. Now with a for loop, the way we have our initialization, the test we're testing for, and then how we update it while it runs the loop. And it will keep running until the test is no longer true, and then it exits the loop. Similar to a while loop. So we use for. We have our iterator or counter that we're going to go through. We go as long as what condition with that iterator is taking place, how that iterator is going to change each time we go through the loop, and then we do whatever we want to do in the loop. We don't even have to use that iterator, as we just execute whatever lines of code are in here, and then we update to our next item. Now, as we're doing this and working with it, one of the things that we are going to need is we're going to need a way to store all these different objects that we work with. So the loop is going to allow us to work our way through the objects, but then we need a way to store them. And what we're going to do that is we are going to use an array to do it. So an array is just simply like a container or box for storing a group of similar like objects. So in processing, arrays can only store the same kind of thing. So you could have an array that stores numbers. We can have an array that stores words. We can have an array that stores objects. In this case, they're edge bounce objects. So we can store whatever we want inside that array. So if I look at our method here, arrays use square brackets. So previously we've been using parentheses, we've been using curly braces, but arrays store square or are defined with square brackets. So we specify what that array is going to contain. We put in a set of square brackets to designate it's an array. Then we have the variable name for what that array is. So in this case, that array is holding a series of strings, and we can put that into it. Now we can have arrays that hold numbers or objects, which is what we are going to be using. Splice is one of the methods. We're not going to worry about our array methods right now. We just need to know that our array is how we can store them. So think of an array as kind of like a box or a folder that you're just putting things into with it. So let's go back into our code. Actually, I want to just get the for loop back on it because that's more That's going to be more relevant language that we'll be looking for. Now, again, so if I say edge bounce here and then put my square brackets designating that this is going to be an array, and then I'm just going to call this balls because I'm going to put my balls into it, so I'm going to have all these different balls that are bouncing around on screen. So we don't really need those variables anymore. So I'm just going to comment those out, and comment these out. What we're going to find is by using an array to store a bunch of objects, our code is ultimately going to be a lot smaller, which is pretty awesome. Because once we want to have a bunch of objects on screen, it's going to make everything much tidier. So now I can say balls is equal to new, and this is where, you know, some of the language here is a little bit messy. We have to then specify how many objects we're putting into it. So we may at one point want to, well, we'll just start out with 1. We'll just make it go through 1. We're going to just put 1 ball into our array, or we'll do 2. Since we had 2 before, we'll do 2, so it'll kind of look the same. So that now puts it in. So what we could do is just say balls, and the first object in the array, notice I put a 0 there. So we can reference objects in arrays by their position. So when we put something in an array, they're stored sequentially, and we can reference their position, and computers count from 0. So we've talked about that before, that computers don't start at 1, they start at 0. So I could say that is a new edge bounce. And then I can say balls 1 is equal to a new edge bounce. And it's grumpy with me because I did not capitalize the B there. Okay. So now I could say balls0.update, balls0.display, balls1.update, balls1.display. I could do that. But instead what we can do is we can now use a loop. So I'll say for int I is equal to 0. And you'll see how the numbering here corresponds really nicely. Arrays start counting at 0, so we're going to make our iterator start counting at 0. I'll say, well, I is less than balls.length. So arrays have a property to them, and that property is length. How many things, how many spaces are storing things inside that array? And then we'll just do balls plus plus, and remember that that is the same as balls is equal to balls plus 1. But when we're writing out arrays, it's extremely common. Oh, not balls. I is equal to I plus 1, which is the same as I plus plus. Curly brace, return twice, close curly brace. So this is our iterator. It starts out at 0. This is our test. We're testing. Is I less than 0? Is less than the number of items in here. Now, 0 and 1, that's the position in the array, but there are currently two objects in my array. So this 2 here, that's the length of my array. And then each time we go through the loop, I will get 1 bigger. So if we go through 1 time, I is 0, so we can execute whatever code I write here. Then I becomes 1. 1 is less than 2, the length of the balls array, so we execute the code that's in there. Now I becomes 2. 2 is not less than the length of our array, therefore it stops running the loop. That's how this functions. And now we can just go balls, square bracket I, square bracket, dot update balls square bracket I square bracket dot display. And now if we run this, it's going to look identical to what we had before. Now if we use a for loop to populate our array, we can very easily now have 2, 3, 4, 5, 10, 100, and this is where it starts to get fun. So right now I'm just going to go 10. And we're not going to use those as is. Now we'll write another for loop. So again, the word for, parenthesis, int I is equal to 0. I is less than balls.length. Notice we have to do this after we initialize balls value, where we say it's an array of 10 objects, and those objects, it's a new array, and there will be 10 objects in it. And then I plus plus. So one thing about working with for loops is once we start writing them, we'll be writing them all the time, and they pretty much always look the same. You just have to figure out what is the test that you're doing. Otherwise it's for int I equals 0, I is less than whatever thing you're working with, however many times you want to go through this, then I plus plus. Now we don't have to just go up by 1, but when we're working with arrays here, it's super convenient to do it that way. And then we just go balls square brackets I is equal to a new, oh, missed my capital on the B. I think my shift key is dying there. And now that creates that edge bounce. So now let's run this. Now you can see we got 10. What I'm going to do is I'm going to get rid of now those original instances that we worked with, just to show you how tidy this code really is becoming. So now when we look at this, we have 10, and our code is clean. They're all different colors, they're all moving independently, so when they bounce off the walls, they're all bouncing independently. It's fantastic. Now if I just add another 0 in, we get 100. So it really is that easy to start increasing the quantity of objects on screen. Now, it's possible that right now we just have these objects bouncing on screen, but I could have a second class of objects that moves differently, that has a different display. Maybe it's rectangles, and maybe they're wrapping on the screen, so they go to one edge, then they wrap over to the other, so they go completely across the screen, and then when they hit the edge, they appear on the opposite side. So we have a lot of options that we could have multiple kinds of objects working on screen. Now I can just add in one more 0 and hit go, and let's see what happens. Now you can see when we start increasing the number how it does start to get a little bit more problematic as to how they show up on screen, and they start to get a little chunkier. Now we can sometimes change some of that here, because if we change their size, it makes it easier for the program to paint it. So part of the difficulty that it's running into while it's putting those objects on screen and looking at, say, 1,000 objects is calculating all of the overlaps of color. So we would need to do some different kind of caching of how the pixels need to be painted during every draw loop in our program. So when we start looking at performance issues, there are techniques and methods we can use where we start figuring out how to paint the pixels more efficiently. Now just for fun, I'm going to speed up my possible speed up from 5 to 10 so they can really start to go on screen. And now let's go up to, say, 3,000 and see. So we can see once it starts, it's able to handle that quite readily and do some pretty fun stuff. So a couple things that we looked at. We've added in a class. Class has properties, a constructor, and methods. So the properties that make up the object, we initialize all of those in our constructor, and the methods are what it knows how to do. In this case, it knows how to update and display itself, which we will again use for every visual object that we work on our different programs throughout the course. Then we are using an array to hold all of these objects together. So it's like a box. I just put 3,000 of these ball objects inside that box, and I'm able to then use a for loop to populate my array with 3,000 new balls. And then I'm able to use a for loop to update and display each ball on screen. So it's a pretty efficient way that we didn't have to write out all of those individual variables. So we're able to store them and work with them more effectively. So good luck and have fun.